So, because there's going to be a lot of multiplication. We're having the monomial problem, the negative problem, and two polynomials multiplied together. Again, we're going to follow our strategy of do the multiplication first. This is one set of multiplication. This is another set of multiplication. Then we want to subtract the answers. On the red side, this is a throwback to when we had a monomial, 5x, times a polynomial. I think the best way to do that is with distribution. If you did it with area diagram, because it is possible, and some people just get like area diagram crazy and they do it with everything. I'll show you what it looks like. I'm not going to fill it out, but your area diagram would look like this. 5x, and then 3x squared minus 7x plus 1. And you've created this area diagram. It's just small. It doesn't look the same way as normal. But you can do area diagrams for any question. Looks a little weird, doesn't it? I'd rather just do distribution, but some people love area diagrams. That's a monomial versus a polynomial area diagram. Awesome. I'm going to erase this thing in slow motion because that's how it works now. Look at that big eraser. We are going to do distribution, mainly because it saves me space. When I do my distribution, I distribute the 5x into the first thing to get 15x squared. Then x cubed. Sorry, I didn't notice how I was multiplying by an x squared. So x times x squared, you add the exponents to become x cubed. Distribute it to the negative 7 to become negative 35x squared. And distribute to the positive 1 to become plus 5x. You've got that big old subtraction sign in the middle. Subtract, is this guy. And then you got the blue side. When you multiply the blue side, you're going to get 20x squared. Then you're going to multiply it over there to get 32, negative 32x. Multiply the 3x squared, you get 15x cubed. And then multiply it by negative 8, 8, 16, 24, negative 24x. I tried so best to conserve space and I still couldn't get it in there. Remember that the blue side should be in a big set of brackets because we want that negative to come into the brackets to go to every single thing. When we bring that negative in, it changes all their symbols. I now have 15x cubed minus 35x squared plus 5x minus 20x squared plus 32x minus 15x cubed plus 24x. Yep.
Shouldn't the 24x be 24x squared?
Definitely. Thank you very much. Right there? Yeah, you are definitely right. It would have been 3x squared times negative 8, and that'd be x squared. Looking at that long string of terms, right? There's a lot there. You've got like terms. It can be hard to pick out the like terms in here. So a strategy I've seen is that people put like some sort of line or symbol underneath of it. So for instance, if I have x cubed, I'll put a straight line under it. Okay, and then I'm like, okay, there's my x cubed. 15 minus 15 would cancel out. Then they would move on to x squared, and they would take all their x squared and maybe put a wavy line under it, right? When you add all those x squareds, negative 35 minus 20 plus 24 would give me negative 31 x squares. Then maybe they do I'm running out of cool lines. I've seen people do it with shapes. Maybe they put a little triangle underneath anything that's an X. Right? And then it like sticks out as symbols. Like, oh, there's my X's. They're the same. That would be plus 37x. Everything has some sort of symbol under it. So I've collected all my terms. I've used them all. I haven't missed any. Right? My final answer would be negative 31x squared plus 37x. You can do the other one for practice on your own if you feel inclined to. Yeah, for sure. We are going to look at example 5, which is kind of a crazy example, but that's okay. We'll try it out. This would be like a top question, right? As hard as it possibly gets, probably for multiplication of binomials or smaller. This says, given that for every value of x, the polynomial, this thing, can be written in this form, determine the values of a and b. They're saying that this and this can be written in the same form. Right? They're the same thing, even though this one's got numbers and this one's got a's and b's. What we're going to do is try to turn one of these into the other form. Right? If we look at this trinomial, the first one, I have no idea how I could change that around. Right? There's no like terms there, there's no multiplication there. This looks pretty simplified to me. But if I look at this guy, I could simplify that thing. Right? Or I could expand it. And when I expand it, I'm going to get all these different terms, and hopefully it turns out looking like this. Okay, so we're going to try it. We're going to expand this thing. We're going to make it x plus a times x plus a. That's what it means to be squared. And then plus b at the end. I'm going to continue expanding, so I'm going to multiply these two things together. When I multiply those two things together using distribution, I'm going to get x squared plus ax plus ax plus a squared, and then still have a plus b. I did that multiplication pretty quick, so I'll give you a chance just to write it down. But all I did was I multiplied my two binomials together, and then I have a plus b at the end. Looking at that, we should have some like terms. We do, right? Ax and ax could combine to become 2ax. Everything else stays the same. So we have x squared plus 2ax plus a squared plus b. All right, we expanded that thing. It should have looked like this guy up here. And it sort of does, but not quite. Right? Like it's a little bit different. If you look, the x squareds match up really nice. And that's perfect. X squared, perfect. If you look at our answer, we have this guy right here, 2ax. I want a different color, 2ax. In our answer, we should have had 20 x's. That means a must equal something to turn 2a into 20. Anybody want to take a guess at what they think a must equal? 10. 10. How'd you get 10? Because 2 times 10 equals 20, right? Like it is kind of just like logical more than anything. But I had to have something here that multiplied by 2 would give me 20. That means a equals 10. If a equals 10, that changes my thing quite dramatically, right? So we could now change a to be 10. This would become 20x. And what would a squared equal? 100. right? Because we actually know A equals 10. The last thing, they said you should have ended up with a 50. We ended up with 100 plus B. That means we can figure out what B is to make it A turn into 50, which would be negative 50, right? If you had 100 minus 50, it would give you the 50 that you're hoping for out there. That means B equals negative 50. That question is definitely just like testing your thought process, right? Like, can you think through what's going on here? It's a little bit of critical thinking, a little bit of problem solving. Awesome. That was a bit of a long one. It's 9:30. You got a good 25 minutes here, though. So if you